This is a weekly summary of interesting news that is relevant for my distributed systems lecture here at the Eastern University of Applied Sciences in Switzerland. My name is Thomas Pocek, and today we have 6 topics. The first topic is about Doom, and I mentioned in lecture 1, will it run Doom in the context of software bloat? It turns out Doom can be implemented within the TypeScript type system, which is probably highly inefficient. It generated what might be the largest TypeScript codebase ever, 3.5 trillion lines of types totaling 177 terabytes. To accomplish this amazing Doom port, the developer had to build an isolated computer within TypeScript's type system, including RAM, disk space, call stack, memory pointers, and execution context. And he implemented all 116 WebAssembly instructions needed to run Doom using only types as logical building blocks. And the developer had to modify the TypeScript compiler by removing limits for stack depth, the type instantiations, and recursion. They also built a garbage collector, a CPU cache, a memory compactor, and other low-level systems. All game data, including maps, texture, sprites, sounds, AI, and physics, had to be encoded in types. And the system needed to process 18 million instructions, with the type checker evaluating 20 million instantiations per second for 12 days straight to render just the first frame of this game. So let's take a look at this very briefly. Here is the video.
This is the 1993 video game Doom, and this is TypeScript. And this is the moment I got Doom running purely in TypeScript's type system.
Amazing. Go and watch the video. It's amazing what this developer did. My first reaction was, wow, impressive, well done. It's just amazing. And my second reaction was then, why? But it's really cool. The next topic is about the state of distributed systems. It's the following article here. The author argues that distributed systems have advanced over the last decade, but programming models remain largely unchanged. Current approaches fall into 3 main paradigms: external distribution, static location, and arbitrary location. External distribution systems hide distribution from developers by using sequential logic on top of distributed databases or CRDTs. While easy to use, they limit performance and scalability because they essentially emulate a non-distributed systems with expensive coordination, as an example, CockroachDB. Static location architectures use separate units of code on different machines that communicate through network calls, and these include service-based models with REST or gRPC, actor system, and publish-subscribe setups. They offer control over performance and fault tolerance, but make it hard to collocate related code and encapsulate distributed algorithms as unified units. Arbitrary location architectures like MapReduce and durable execution frameworks let developers write code as if on a single machine, with the runtime deciding on how distribute execution. This solves collocation issues but removes control over scaling, fault domains, and network communication. And all these models, so the author argues, struggle to balance control with ease of programming. They either force developers to modularize code on machine boundaries rather than semantic ones, or they take away control over where and how code runs. This becomes especially problematic when implementing protocols like two-phase commit that needs specific logic placed in specific roles. Even for large language models, which struggle with scattered information, a programming model that keeps semantically connected distributed logic collocated would be better. So the author argues, and we need a native programming model for distributed systems like Rust is for memory safety that provides both explicit control over placement and the ability to co-locate code that spans multiple machines. And so this is what the author calls for a native programming language, a so-called Rust for distributed systems. And in this discussion down here, very interesting discussions, the author of the Unison language here, they sparked a discussion. There was Rama mentioned, which is another programming platform, and Chorus was mentioned as well here, which is a programming paradigm to coordinate the behavior of multiple nodes, which shows that there are actually programming models for this issue, but the pain with the current paradigm seems not high enough to look into alternatives. The next topic is about the question of the value of HTTP2 for internal server communication, and it's the following article here. While HTTP2 offers important benefits for internet-facing connections, these advantages diminish significantly within data centers. HTTP2 was developed in 2009. Originally, it was called Speedy to reduce page load latency. And the main problem it solved was HTTP 1.1's limitations of using only 2 concurrent connections per domain, which created bottlenecks when downloading many resources. And HTTP2 introduced multiplexing of requests inside a single TCP connection. However, this multiplexing advantage becomes nearly irrelevant within data centers where network latency between servers is extremely low, under 1 millisecond. The round-trip time between an application server and its load balancer is typically dwarfed by actual request processing time. Additional connections between load balancer and application servers usually have a long lifetime, avoiding the TCP slow start issue that affect newly established connections. Another HTTP2 feature, server push, has been removed from specifications after proving counterproductive. Browsers have dropped support for it because pushed resources often duplicated what was already in browser caches, and this feature has been replaced by 103 early hints, which also works with HTTP 1.1. Implementing HTTP2 all the way to application servers adds complexity without meaningful benefits. The protocol is binary and harder to debug than HTTP 1.1. It also traditionally required encryption, adding certificate management overhead to internal services, though the specification itself doesn't mandate encryption. For most deployments, it makes more sense to handle HTTP2 at the load balancer or reverse proxy, which can translate it to HTTP 1.1 for internal communication. I tend to agree, but I would argue encryption should be mandatory in internal networks as well. So this point I do not consider as an advantage, but overall I also agree here. The next topic goes into the direction of supply chain attacks. I will talk in an upcoming lecture about dependency and supply chain attacks. And this article here is about GitHub scam repositories stealing user data. An investigation has uncovered thousands of malicious GitHub repositories pretending to be game mods, Fortnite, Roblox, or cracked software, Photoshop, that are actually stealing sensitive user data. When downloaded and executed, these files run the Redox Stealer malware, which collects cookies, passwords, cryptocurrency wallet information, gaming accounts, and other valuable data from victims' computers. This data is then silently uploaded to Discord servers where scammers search for crypto wallet keys, bank accounts, social media credentials, and gaming accounts to steal. The investigation identified over 1,000 suspicious repositories created following a pattern found in a step-by-step guide shared in an online forum. The malicious code targets a wide range of applications and services, including MetaMask and Exodus, game platforms like Steam, Epic Games, Riot Games, social media accounts like Discord, Instagram, TikTok, streaming services, Netflix, Disney Plus, and financial services, PayPal and Binance. And despite how easily identifiable these repositories are through pattern recognition, most remain active on GitHub. And also this report links a list, an Excel sheet of those repositories. I checked few of them and indeed they are still active. They are for whatever, some hacks, this is for Roblox, and they are still online. The next topic is about sea cables. I talked about sea cables in the first lecture, and a recent International Submarine Cable Resilience Summit in Nigeria brought together governments, industry leaders, and international organizations to strengthen the global undersea telecommunication network. The summit produced a declaration outlining commitments to improve cable protection through risk mitigation, route diversification, and faster deployment and repair process, since more than 99% of international data traffic travels through approximately 500 submarine cables spanning 1.7 million kilometers worldwide. With 150 to 200 cable faults reported annually, disruptions significantly impact economies, information access, and public services for billions of people. Now, this is a press release, and if I only knew what they actually want to do, oh wait, they have here a statement. They want to establish a working group, so I guess they want to solve problems with more meetings. I'm not sure this is a press release. It's very light on information, and I keep you updated as soon as I know more about these topics, because I think sea cables, it's a very interesting topic. The last topic is about the Bitcoin crash, and it's the following article here. Bitcoin has slightly recovered to 84,000 US dollars. So currently we are here at 84,000 after experiencing its largest 7-day drop in history, falling 21% between February 21st and February 28th, and briefly touching 78,000 US dollars. The correction triggered over 1.6 billion US dollars in leveraged long positions liquidations, contributing to market volatility. And some explanations for the crash is the Trump administration's trade policies, particularly the announcement of 25% tariffs on European Union imports, which may have affected both crypto and traditional markets. For sure, the traditional markets, maybe also the crypto markets. And I was talking last week about Bybit, the security concerns following a major theft at the Dubai-based crypto exchange Bybit, where hackers stole digital assets worth 1.5 billion US dollars. That also caused, interestingly, a Thorchain developer to step down, as the hackers funneled some stolen money through Thorchain. It's the following article here. And here I want to mention that the article is actually wrong here. The money is not laundered, as it still can be traced, so no laundering happened, but they used Thorchain to funnel these funds. And in this article here, the analysts, they remain very optimistic, and some analysts here predict that Bitcoin will even go up to 230,000, almost to 300,000 in December 2025. But to counter these overly optimistic projections, keep in mind it also could go down to maybe, I don't know, 50,000 US dollars, or we could enter a new crypto winter. Everything's possible. It can go up, it can go down. It's a gamble.